The diagram shows triangle ABC. Vector AB is 3A, so the vector here is 3A. Vector AC is 2B. Vector BE is 3 lots of AC. I'm just making notes of that. So 3 lots of AC. AC is 2B. So 3 lots of 2B. So that would give us 6B. All right. D is the point on BC such that BD to the ratio of DC is 3:1. So this is D, and the point BC, we have B to D, so B to D is 3 to the ratio of 1. And if we write that as a fraction, so 3 to the ratio of 1 as a fraction, that would be 3/4, and that would be 1/4. So I'm going to write that as a fraction rather than as a ratio. So I've got from here to here is 3/4 of the line BC, and from here to here is 1/4. Prove that ADE is a straight line. So we want to prove that A to D to E is a straight line. All right, this is a vector question, and we're going to start with, well, what is this line A to D? So A to D is going to be A to C plus C to D. A to C is 2B plus C to D, which we don't know. So the question is, what is C to D? Now C to D is, if we look at that carefully, so C to D is 1/4. That's 1/4 of this lot, 1/4 of C to B. Okay, but we don't know what C to B is. So to work out C to B, we'll look at what we need to do. So from C to B, we're going to go this direction. So that's 1/4 of going back. So that's minus, actually, because we're going C to B, we're not going to go back. We're going to go in this direction. So C to B, so we're going this direction. So we're going to from C to A plus A to B. Now C to A is minus 2B, and A to B is 3A. So we're going to go minus 2B plus 3A. and that would give us, normally we prefer it the other way around, so we prefer conventional, we like it to be the positive come first, so we prefer 3a minus 2b. A quarter of 3a, that will give us 3/4 a minus 2/4 of b. All right, so once we've worked out what that is, remember this is C to D, and that's going to be replaced by this. So if I rub everything else off that I don't need, so we have A to D is going to be 2b plus 3/4 a minus 2/4 b. And then what we want to do is try to simplify that. So A to D is going to be 2b minus 2/4 b plus 3/4 a. Now the 2 as a fraction, so times that by 4, times that by 4, we would have 4b over 4. 4 times 2 is 8, sorry, so we would have 8b over 4 minus 2b over 4 plus 3/4 a. 8 minus 2 would give us 6, so we have this part here is going to be 6b over 4 plus, we still got 3/4 over 4. If we factorize that, 4 would definitely come out, so 1/4. We also have factor of 3 and 6 is 3. So overall we would have 2b plus a. And that is what the line AD is. So I'm just going to write the line AD here, just so that I remember what it is 3/4 2b plus a. Next, we're going to find the line AE. So the line, we've worked out the line AD, which is that line. We're now going to work out the line AE. So the line AE, if I rub all this off, the vector AE is going to be, we can go from A to B, plus B to E. Now A to B is 3A and B to E is 6B. If we factorize that, so we have 3A plus 2B. and that's vector AE. So to show that the line ADE is a vector that's on a straight line, we can look at the two vectors. So A to E is that A to D was 3/4 because we've got A plus 2B, so we can write A plus 2B because that's the same thing. A plus 2B is the same as 2B plus A, so we could swap those two and said, well, it's A plus 2B. So if we look, they have the same vector. They've got A plus 2B, so they must be parallel. And what's happening is that AE, or you can say, well, AD, vector AD is actually 3 lots of vector AE. Not 3 lots, a quarter of vector AE. So that's the first expression, the fact that they're both parallel to each other because they have the same vector. So they both have A plus 2B and A plus 2B. The second part is to prove they are on a straight line. That one is not too difficult to do. They are on a straight line because AD, vector AD, and vector AE both share a D in common. So vector AE is actually AD plus DE. And as a result, because they both share the vector, they both share the point D, it means that they both have point D in common. Therefore, the line ADE is a straight line.